Evening everyone, welcome to the video on the sample titration questions and some answers. So during this video I'm going to pick some sample questions and I will talk you through how to do the calculations in them. So the first question we're going to look at is the 2016 higher level paper, and in that year it was the titration for ethanoic acid and in the percentage of ethanoic acid in vinegar. Again, as always, to draw your attention, guys, there is 1, 2, 3 questions here that do not involve calculations and bring you up to 29 marks out of 50. So straight away you can get 58% in this question without having even attempted a calculation. The two calculation questions here are part C and part D. So in part C of this question, we are asked to calculate the number of moles of sodium hydroxide in each 25 centimetres cubed portion. To calculate this, we need to look back at the question and see what information we can gather from this. Well, in the question, we can see that we weighed out 1.2 grams of sodium hydroxide into 500 centimetres cubed. Unfortunately, that is not what we want, but that is the information that we are going to start with. So we know that there is 1.2 grams in 500 centimetres cubed. My question is asking for us to calculate this in moles per 25. So step 1 is to calculate from grams to moles, and to do that I divide by the relative molecular mass. Now we know to calculate the relative molecular mass we must add it up. So sodium is equal to 23, oxygen is equal to 16, and hydrogen is equal to 1, giving me an answer of 40. So we're going to multiply it by 40, and we're left with an answer, or we're going to divide it by 40, apologies. We're going to get an answer of 0.03 moles in 500 centimetres cubed. I don't want it in 500 centimetres cubed, I want it in 25 centimetres cubed. And the easiest way to do that, guys, is to divide by 20. Why 20? Because 20 goes into 500 25 times. So 0.03 divided by 20 gives me 0.0015 moles in 25 centimetres cubed. So that is part C, part 1. Now to calculate C, part 2, we're looking for the number of moles of ethanoic acid per centimetres cubed of dilute vinegar. To carry out this step, we must look at the balanced equation, and we must look at the ratio. So in our balanced equation, we can see that for every 1 molecule of ethanoic acid, I have 1 molecule of sodium hydroxide, which gives me a 1:1 ratio. Now from the previous question, we know that we have 0.0015 moles of NaOH. If I have 1 mole of NaOH, I will have 1 mole of ethanoic acid, and I know this from my balanced equation. So if I have 0.0015 moles of NaOH, I must have, according to my ratio, 0.0015 moles of ethanoic acid. Now, this 0.015 moles corresponds to the amount of moles that we used in this particular titration of vinegar. So in order to figure that out, we need to go back to our question and figure out how much vinegar we did use in this titration. And when we read the question, we can see that it says, on average, 18.75 centimetres cubed of the diluted vinegar were required to neutralise the 25 centimetres cubed of NaOH. So that means I have 0.0015 moles in 18.75 centimetres cubed. But I don't want it in 18 centimetres cubed, I want it per centimetres cubed. And that's something we have to be very careful about in this question. I don't want it per litre, I want it for 1 centimetres cubed. So in order for me to calculate that, I need to divide my 0.0015 by 18.75, and when I do that, I calculate to get 0.00008 or 8 by 10 to the minus 5 moles per centimetre cubed. We're now going to have a look at part D, and part D is asking us to calculate the concentration of ethanoic acid in the original vinegar. Now, in order to calculate that, we need to go back to our question, and we can see in our question that we diluted 25 centimetres cubed of vinegar to 250, and that gives me a dilution factor of 10. So, what I know so far is that I have 0.00008 moles in 1 centimetre cubed. I want that per litre, so I'm going to multiply it by 1,000. And I also want it in the original vinegar, so I'm going to multiply it by 10. So don't forget the 1,000 to get to 1 litre by 10 is my dilution factor. And when I carry out all of those steps, I get a much bigger answer of 0.8 moles per litre. The final part of the question then is asking us to calculate our ethanoic acid as a percentage weight by volume. So in order to do that, we need to remember, what does weight by volume mean? Well, it actually, our percentage weight by volume. What does that actually mean? Well, that means how many grams are in 100 centimetres cubed. All we know so far is that we have 0.8 moles per litre. So there's two ways that you can go about this. I'm going to go with the first way, and I'm going to switch my moles to grams. And the easiest way for me to do that is to multiply by my relative molecular mass. Now, when I'm doing this, I always add it up at the side. So CH3COOH. I have 2 carbons, so that's going to be 12 by 2. I have 4 hydrogens, so that's going to be 1 by 4. And I have 2 oxygens, which is 16 by 2. All of that adds up to give me 60. So I'm going to multiply my 0.8 by 60, and when I do that, I get 48 grams per litre. But we know in percentage weight for volume, I don't want it per litre, I want it per 100 centimetres cubed. So the final step to go from 1 litre to 100 centimetres cubed means to divide by 10. If I divide the litres by 10, I must divide my grams by 10, so I end up with 4.8 grams per 100 centimetre cubed. To write it properly, we would write 4.8% brackets weight by volume.